Hi, today we're going to go over direct proofs, but we're going to start with some information that builds off of our last lesson. And it's about conditionals. So we know a conditional is the P then Q form right here. Now, in order to have a biconditional, we need to prove that the conditional and its converse are both true. So a conditional, remember, is always true from the beginning. We know this is true. If an angle is acute, then it measures less than 90. That's like the definition of acute. Now, the way definitions are built, that when you read them backwards, the Q then P, that they should also be true. Now, I can start with the word it. What is it? It is the angle. If the angle has a measure less than 90, then it is acute. Now, I think we would all agree that this is true. Good definitions are always true, written as the conditional and its converse. Now, for a biconditional, what we're going to do is we're going to put these together. And in the middle, we put IFF. Now, IFF is an abbreviation. IFF stands for if and only if. You're going to hear me say this a lot. Mathematicians are lazy. We don't want to write it out. So if you want to write it out, you can. If and only if. You use this notation, and that indicates that to the person reading it that both ways, converse and the conditional, are both true. So the way that we're going to do this is we're going to go back to the original, because this is our new form. It says we start with the P. We write all the information that is the P. So we're going to say an angle is acute. Now, we're going to use the new notation, IFF, if and only if, and I don't care. I've seen it both ways, all uppercase, all lowercase. You can make the I up or the F's lower. We all understand what it means. So just put IFF. An angle is acute, if and only if. And now we're going to talk about the Q. And the Q was, it has a measure less than 90. It has the measure less than 90 degrees. Okay, so all of this sentence, this is called your biconditional. Now, when you see this new notation, again, that's your clue that it's a good definition. It's true both ways, the conditional and its converse. So, a fact, a statement that can be written as a biconditional is both a conditional and the converse are both true. Yeah, we know that. Okay, so what we're going to do now is we're going to first see if this is in conditional form. And right away you should know, because I see that it doesn't really start with the word if. And there's not a then. So the first step is to write it in conditional form. So a right angle has a measure of 90 degrees. Okay, so I'm going to say if the angle is a right angle, then it measures 90 degrees. And hopefully you guys will all agree this is true. And because our conditionals are supposed to be true. Now I'm going to write this as my Q then P, which is called the converse. So I'm going to start with if it measures 90, but who's it? It is the angle. So if the angle measures 90 degrees, then it's a right angle, which again, I hope everyone will agree is true. Now we're going to write the biconditional form, which is P and then an arrow with double arrows going to the left and to the right, and then Q. Okay, so again, I'm going to go back up to my original. I'm taking off the if, I'm taking off the then, and I'm replacing the then with IFF, which means if and only if. Now remember, you can only write a biconditional if you have a true statement for the conditional and the converse. Okay, so I'm going to say my biconditional is the angle is a right angle if and only if it measures 90 degrees. And again, that's your indication. As soon as you see this, it's true. It doesn't matter if you read it frontwards or backwards. Okay, next sentence. I notice right away it's in if-then form, so that's one step I don't have to do. So let's do the converse form, Q, then P. So who's they? They happen to be the angle. So, and I messed up. If the angles are equal, then the two angles are right. Okay, so I have to decide if this is a true or false thing. So if the angles are equal, then they're a right angle. And we know right angles are 90 degrees. So can you have right angles, or can you have angles that are equal that aren't 90 degrees? And you can. You can have two 30-degree angles or two 40-degree angles, and I could keep giving you examples forever, right? So this is a false statement. So I am not able to write a biconditional. So there is no biconditional for this one. Can't do it. Okay, so now we're going to talk about a syllogism. A syllogism is an argument in the order A, then B, B, then C, and then we have this weird little dot thing. This dot thing means therefore. It's just a shorthand math thing. It's kind of fun to write, or do the dots instead of writing the word therefore, and A, then C. So what's happening is it ends and it starts with the same part of a sentence. And so you're left with the A and the C. And let me show you how this works. And I'm just going to make one up. And let's see. If the students study math, then they are happy. Okay, that's my first sentence, and let's label this. This is my A, and this is my B, okay? Now, we're going to assume this first sentence is true. I realize some of you are going to say, I'm not happy when I do math. Or just for argument's sake, this is true, okay? Now, we're going to do B, then C. So, I have to start with the information that I ended with. They are happy. So who's they? They happens to be the students. So if students are happy, then they, and I can make up anything I want because this is just a silly one. So if students are happy, then they smile. I don't know. Just something silly. Now, I have my B, and then my ending of the new sentence is my C. So now I'm going to do my A, then C. So I'm going to start either by writing the word therefore, or I do my three dots. And I want to start with the very first sentence that I had. If the students study math, then they smile. And that is my final conclusion. If the students study math, then they smile. Oops, for the they smile. Okay, now again, it doesn't matter how ridiculous this ending is, as long as all of the steps leading up to the conclusion are true. And this is just a ridiculous one. If we have one that's based on real math facts, then it would work out. Now, last time we talked about Euler, and it looks like Euler, and we had a diagram just like this one. Now, we're going to expand it. We're going to combine it with another Euler diagram. And so we're going to finish with this big diagram. Okay, so now we can have multiple circles. So what this multiple circles represents is a syllogism. And a syllogism is a type of direct proof. Okay, so remember, you work from the inside out. So you would go from A to B, B to C, and then A to C as your final step. Now, if I had more circles than that, then you would just continue the pattern, and it's pretty easy to do. So here's a quick example. Okay, so if the people are Greek, let me rewrite that. If the people are Greek, then they are humans. That's my first sentence, A to B. Now let's do B to C. If they, who's they? If the people are, now I have to start with the information that I ended with. So I'm going to say are humans. If they are humans, then they are mortals. Okay, so I'm going to wrap it up. I'm going to say A to C. So this is therefore, if the people are Greeks. Now, if you don't understand where I got that from, what I'm doing is I'm taking the very first sentence and my very last sentence, and I'm combining them. So if the people are Greeks, comma, then they are mortals. Done. So when you do it, you have to write it all. I know it's a lot to write, but you have to write all of this if you're going to write out what the Euler diagram represents. Okay, so there. Took away the highlight. Maybe it looks better. Okay, so we can extend this out. And if we were doing this in class, I'd have the class help me, and we would write this huge, long syllogism on the board. Now, each step is called the premise. So let's go back up. So this first step here, that's a premise. And then this is a premise. And then this one is called your conclusion. Okay? And so like here, that's one premise, two premise, three premise, four premise. And then the last one is your conclusion. Now, we can make up one. And usually people like to make them, I don't know, make someone die. It's usually me. I don't know why. But let me just try to come up with one where I don't get hurt. If Mrs. P sits in the sun, then she'll get burned or sunburned. So that's my first sentence. That is my A to B. That is one premise. If I sit in the sun, then I'll get burnt. Okay, if I can't say she, I gotta say you. So if Mrs. P, let's say, gets sunburned, then she will, and then again, this is just silly, I gotta make it up. She will need aloe. Sure. That's the second premise. That would be B to C. Again, there is a pattern, the end and the beginning match. And if I want a third premise, I would have to start with something about needing aloe. So if Mrs. P needs aloe, then she will go to Target. All right, that's my third premise. Now, again, let's look at this pattern that's forming. If she needs aloe, and then I put that here, and I have a new ending. I just realized. All right, so again, if Mrs. P needs, or if Mrs. P goes to Target, then she will shop for hours. I don't know, I'm just making this silly. Okay, again, we have a pattern that I ended and started with the same information. So she will go to Target, go to Target. Now, I could keep going with this forever, but let's wrap this up. So my last sentence needs to say, therefore. And right here, we should really have therefore. Okay, so therefore what? Okay, so if you look, I'm going to take my very first sentence and my very last sentence and combine them. Again, it doesn't matter how silly it sounds. If every single step is true, the conclusion has to be true, even if they don't relate and they sound ridiculous. Okay, so if Mrs. P sits in the sun, then she will shop for hours. All right, they really have nothing to do with each other, but for the law of syllogism, that means they have to be true if every step leading up to it is true. Okay, so again, this is an example of a direct proof. This is where I give you a beginning statement and we argue to a conclusion, and really there's only two kinds of proof. So just remember this. There's direct proofs and there's indirect proofs. And we have one entire lesson about direct proofs, and they're very, very different, and you will be able to tell the difference. Okay, we're almost finished here. We have two more vocabulary words, and we have a theorem and postulate sheet. And so let's define what a theorem and a postulate is. So these are statements that we use to prove everything for the entire course. So a postulate is something that's usually a little bit easier to understand. You really don't have to prove it. It seems to be pretty much common sense. It's a statement that is already accepted as true without proof. So you never have to prove a postulate. And a theorem, let's look at the word theorem. It's kind of like the word theory, right? So you have to test and prove theories. So a theorem is a statement that must be proved from reasoning deductively from already accepted statements. Now, what it means already accepted statements is we have to use other theorems and other postulates and other definitions to prove that it works. And so within this course, we use these proofs up here, these direct proofs, to prove new theorems, okay? And so it's all logic. And it's a very different way of thinking, and it's not algebra at all. And so get your head out algebra mode. We have to think logically. So every lesson that I teach you, what's going to happen is you have to use information from the previous lesson to help you get through the new lesson. So on the homework, you're not always going to just have that day's homework. You're going to have that day's homework plus every other day prior to it. It's all very high level thinking, lots of word problems, and it's, again, not algebra. It's very different. So you're going to have questions, you're going to have concerns, you're not going to know what the question's asking. And, just do your best and ask questions and don't sit in silence and struggle. If you need help, I'm here. I can't help you if you don't reach out. And I'm more than happy to help you. So please, try your assignments, and, there's a limited attempt. And again, reach out if you need any assistance. And that's all. See you guys later.